Alright, welcome. So, like I said, got one or two questions from a few past papers and Roberigisa the compound angles more. Okay, so got to about a few IEB questions and we'll see what, how far we are after maybe 10 minutes or so. Fine, so now the first one is this. We are given that cos beta plus sine beta is t. So tshwanetse express this in terms of t. Okay, so this means tshwanetse simplify this, and then after I simplify where we see cos beta plus sine beta, we'll replace that by t. That's basically what it means. Okay, so well, tshwanetse ka this first. So I'm not going to copy this down. Now, notice that in the denominator, there isn't much that you can do. You just have to apply the compound sign. So let's do that. So this elegant sine beta, sorry, elegant sine beta cos 45 minus sine 45, and then cos beta. Okay, now cos 2 beta, remember from what we did here, you basically have three identities to choose from in terms of cos 2 beta, but you need to be careful how you choose a roberekisa efe. So you need to choose something that will sort of somehow help you in a way get to where you want. And that is basically the tricky thing about trig. Making sure that you choose what will, quickly help you. I mean, any of this can be chosen, but the one it will lead to the answer quickly should be this one. And the reason I'm saying this one here is because let's get difference of two squares. Okay, and from this difference of two squares, if you factorize this, it's gonna be cos theta plus sine theta, and then multiply by cos theta minus sine theta. And I know this will replace I got t. Well, that side will got beta, but it's the same thing. Okay, so I'm going to go for that option because I know I can factorize the difference of two squares, and then I'm gonna have something like this. Okay, and usually, the correct choice comes with more practice, basically. So I'm going for cos beta minus cos squared beta minus sine squared beta. Okay, and then I'm going to factorize that and say it's cos beta minus, or let's go for plus first, plus sine beta, and then multiply by cos beta minus sine beta. Everything over sine beta. So this will just be sine beta. Cos 45, if you go to your special angles, we talked about this. This elegant is 1 over root of 2 minus another 1 over root of 2, then cos beta. Okay, so there isn't much I can do in the numerator, so I'm just gonna keep those as they are. Sorry for that. Sine beta times cos beta minus sine beta. Okay, and then down here I'm going to factor out 1 over root 2, and then have sine beta minus cos beta. And just remember what I said at some point, that your algebra should be well polished for you to be able to master trig, you know, because really so far it's all just algebra in a way, you know. Fine, so all that over. Now here's the thing, I don't have sine beta minus cos beta anywhere godimo, so I cannot say this a canceller something out, but I can force it to cancel something out. Okay, now notice that if we factor out a negative class, okay, so it's more like having x minus y, and then I'm factoring out a negative sign. Okay, so if I factor out negative 1, for instance, this is going to be minus x plus y, because this times this ilompa x, and then that times that ilompa the minus y. And then I can also write this as just x minus, no, sorry, we can write this as y minus x. Okay, I mean 2 minus 3 leganale minus 3 plus 2. Okay, so that's why I can flip those two around. I'm gonna do the same thing here. So if I factor out a negative, kilonale minus sine x, sorry, minus sine beta, and I'll need a positive cos, so go call this as just cos beta. So if I multiply in the negative, kilonale minus cos beta, which is that, and then plus sine beta, which is that. The reason I get is so that it can be clear that this guy will cancel out that guy. Okay, I mean you can obviously cancel them out, minus sine plus cos, but for you to see clearly, you know, I had to change it. So this is now cos. Now we have cos beta plus sine beta, and we can replace that by t. So we can do that right away actually. So I'm going to replace my cos beta plus sine beta by t. So it's gonna be t over negative 1 over root 2. And then I mean you can simplify this further and say this is the same as t divided by minus 1 over root 2, which is the same as t times root 2 over minus 1, which is just minus root 2t. So this whole expression in terms of t is minus root 2t. Okay, let's go for another one. Now in here we almost have the same thing. So this is now 2016 paper, again IEB. So cos A plus sine A is k, so we can quickly expand this. So okay, it's gonna be cos A times cos 45 plus, because renale cos, so it's gonna be plus sine A times sine 45. Okay, so this is 1 over root 2 cos A plus another 1 over root 2, then sine of A. Raga factor out 1 over root 2, eberenale cos A plus sine A. And then cos A plus sine A is k. So we end up with k over root 2. But obviously we have to rationalize this. So to rationalize this, you can multiply by root 2 over root 2. So we don't only root 2k over 2 as your final answer. Okay, and then I think there was a follow-up question also from this. So this is number 2. So we still have that cos A plus sine A is k. So we just have to apply that here now. So this is 1 plus, so this, remember, can be written as 2 sine A cos A. Okay, but now from this thing I have to find a way cos A plus sine A. Okay, so that I can replace that by K, because now I can't just replace K here, so we have to do some work. Remember, your grade 11 identity, 1 can be written as cos squared plus sine squared A. Okay, so go call this as cos squared A plus sine squared A, then plus the 2 sine A cos A. The reason I'm doing this is so that I can factorize. You know, that's the thing, trick. You need to be in a position where you see these things as quickly as possible. And in many cases, my experience has been that, you know, learners take time to see what they have to do, not that they don't know what they have to do. So the more you practice, the better you get. So now this can be factorized. I mean, this is more like having x squared plus 2xy plus y squared. You know, remember I said your algebra should be on point. So if you factorize this by factorizer as x plus y times x plus y, which is just x plus y all squared. So this can be factorized as cos A plus sine A times another cos A plus sine A. So in the end, we'll end up with cos A plus sine A all squared. And we'll replace that cos A plus sine A by K. So we'll end up having K squared. So this is legally K squared in terms of K. Okay, let's take one more. So again, we are still on IEB. This is now 2017. So if sine 31 degrees times cos 22 plus sine 22 times cos 31 is K. Okay, now you need to identify that with one of this, your compound angles. So let's check. So we have sine cos, sine cos. So sine cos, sine cos. So basically, and the sine, I think, get plus that side. Let me just confirm here, get plus. So we are here in a way. So therefore, whatever that is given can be written as that. Okay, so this whole thing is just the same as, so you compound their sign. So get sine of, because get plus here, remember the sign, you know, the sign doesn't change. So this is sine 31 cos 22, then sine 22 cos 31. So this is just 31 plus 22. So basically that elegantly just sine of 53. Okay, remember I haven't looked at the questions. Now what this means is that sine 53 is K, and because sine get trig ratio, it means we have K over 1. And what this further means is that the opposite side get K and the hypotenuse side get 1 in some right angle triangle. So on some right angle triangle 90, and this angle here give 53, and the opposite side is K, the hypotenuse side is 1. And then by theorem of Pythagoras, if you butter this side, it's gonna be r squared minus that, so it's 1 minus K squared. Okay, so just from expanding what is given before even looking at the questions, I have this. Okay, so in many cases, just try and spend some time obonoroga explore what is given before looking at the questions. Okay, but do not spend too much time on that. You know, I always say that to my students, but Anyway, so now let's look at the questions. Sine 53, I mean, this is k. We already have that from here. Well, you can have it as k over 1 if you like, but it's k. Now down here we have cos of 143. Notice that this is the same as cos of 90 plus 53. Okay, so you should always try and relate this to what is given or to what we have. Okay, so I know that sine 53 is k, so the angle important from what we have is 53. So if you can write that in terms of 53, then you'll have your solution. Now this is now cos 90 plus it's negative, but the 90 will change like that to sine, so this is just minus sine 53, which will then be minus k. Okay, I mean it's a negative, well, but anyway, that's story for another day. But your answer is minus k. Now here we now have sine, we have cos, okay, plus. So let's get compound your cos and come minus, because remember the cos, if you only plus, then utsonzo only minus, utsonzo subtract the two angles. The two angles are 7, 5 and 22 degrees. Okay, so this is just cos of 7, 5 minus 22 is 53. So you see, one way or the other, you have to have that 53. Okay, and then from here, cos 53, remember cos is adjacent over hypotenuse. On some right angle triangle, that angle of 53. So in this case, it means you need to take all this information and bring it there, because there's a mark for having that right angle triangle and your adjacent side. So adjacent side from that is square root of 1 minus k squared over the hypotenuse, which is 1. So your final answer in the end, 1 minus k squared. Okay, so I don't know if I have some follow-up question. No, that's just an identity. Okay, so let's maybe stop here for this video, and I'll do some more in the next one. Bye for now.